Welcome back. Today we will be talking about the inverse trig function. So as you can see in these two definitions, these two statements, if a function is defined such that each range element is used only once, then it is a one-to-one function. And for a function to have the inverse function, it needs to be a one-to-one function. So by definition, f inverse is nothing but where the coordinates are y and x such that x and y coordinate belongs to f. So what they are trying to say that in the inverse function, the x and y, they switch from the original function. So the domain of the original function becomes the range of the inverse function. Range of the original function becomes the domain of the inverse function. F inverse, f to the power of -1 is not 1 over f. So avoid that mistake. The symbol f, -1 on the top of the function x is read as inverse function. So avoid this common mistake. It is not the reciprocal. The other thing that we need to keep in mind is the inverse of trig function. So let's start with the sine function. So we can say y is equal to sine inverse x. So whenever we have inverse, we need to ask ourselves at what angle of sine the answer will be y, or the value will be y. So I can rewrite this function as at x is equal to sine y. So at what angle the value will be x, right? So because we can rewrite it. So x and y, they are just the variables, right? So in this case, y is working as the angle. Sometimes the x will work as the angle, or theta can be written as the angle. Another thing, sine inverse x can be written in two ways: sine to the power of -1x or arc sine x. So it is not read as to the power of -1, it is just sine inverse. So y is the angle in the interval -pi/2 and pi/2. So if you remember the graphs of the sine function, -pi/2 and pi/2, what was that? That was the range of the sine function. So as we have discussed earlier, the range of the sine function will become the domain of the inverse function. Domain of the sine function will become range of the inverse function. So the domain is -1 and 1 because it is a continuous, and the range is -pi/2 and pi/2. So the y is the angle in the interval -pi/2 and pi/2. So whose sine is x, and x and y, they both have the intercept at 0 and 0. So the domain, so the whole entire function of the sine function, if I tilt it, maybe let's rotate 90 degree, that will be your sine inverse, because they are the x and y, they will be swapped. So since it is a periodic function, for a sine function or the cosine function or the trig functions to have the inverse, it needs to have a domain restriction. Without the domain restriction, there cannot be any inverse functions, because y repeats over and over again. So without range restrictions, there is no inverse function. Okay, that is very, very important. Now, keeping this in mind, when we are talking about the graph, how the graph will look like. So remember, the x and y, they are swapped, right? Instead of having the waves on the x-axis, the waves will happen on the y-axis. So let me reconstruct it again. See, you can see The waves are on y-axis. In the basic y is equal to sine x function, the waves was on the x-axis, right? So it will reach the maximum height at pi 2 and minimum on the negative side of the y-axis. The loop will have the maximum at negative pi over 2. So as you can see, this is symmetric with respect to the origin. And this is what kind it will be. It will be an odd. So basically the sine and cosine function, technically they are just the graph. They are not the function, because for a function to be a function, it should pass the vertical line test. And as you can see from this graph, it doesn't passes through the vertical line test. It is just a graph. It is just a different way of understanding this. So, and as I said earlier, it will be considered as odd. Now, this is how the two graphs of sine x and the sine arc sine or sine inverse x, we have compared the two graphs, and we are comparing it on the interval pi 2 and negative pi 2. On the same line, this is how we can compare the cos x and cos inverse x. So let's talk about the properties of inverse cos. So the domain of the cos function will be the range of the inverse function. Range of the cos function will be the domain of the inverse cos function. And we can see the spiral or the waves are on the y-axis. If you look minutely, it intersects on the x-axis and the y-axis both. So it intersects at pi 2 on the y-axis, and the loop will take maximum, that means the hill that it is creating will be at pi. The domain will be negative 1 to 1, that means those are on the x-axis. And 1, 0 will be the x-intercept. One thing that is very, very important is that the inverse cos function is neither even nor odd, and it is symmetric with respect to the origin. So let's define the range. Range will be restricted from 0 to pi. So that is what the range restriction will be there. The domain is negative 1 to 1, and the range is 0 to pi. Now the intercepts. So as I said, it has the separate x and y intercept. As you can see from the graph, x-intercept is 1, 0, and the y-intercept is at 0, pi over 2. So whenever you think about the inverse functions, imagine the original function. That means the basic functions. Now the inverse trig function will be something like this. So the inverse trig function, it will have the horizontal asymptotes, because the original function, it has the vertical asymptote, right? If you understand, we did the logistic models. It is one of the models that has the two horizontal asymptotes. So inverse trig functions like the sine function, so it is an odd function. Domain is negative infinity to infinity, and the range is restricted, so it is negative pi over 2 to pi 2. Intercept for x and y intercepts they are both at 0 and 0, right? So having a basic understanding of the parent function, that means the original function, not the parent function, will help you to understand the inverse function a little bit better. Now, the other thing that we need to keep in mind, let's have the unit circle summary, how the inverse functions behave, where it will be positive, negative, and where will be the range restriction, in which quadrant there will be a range restriction on the unit circle. Now, this chart will really help you in solving the question and understanding that your answer should be positive or negative, where your graph, the particular value will lie. So, as I said, it is a summary of the inverse function on the unit circle. I'm not comparing it on the graph. Just imagine the unit circle now. On the unit circle, we have the four quadrants, quadrant 1, 2, 3, and 4. So if you remember ASTC, all students take calculus or add sugar to coffee. So positive, then in the second quadrant, cos is negative. In the third quadrant, sine and cos is negative. And in the fourth quadrant, sine is negative. So remember about the range restriction. So based on the range restriction, if you look at the unit circle, we have 0, pi, 2, pi, and 3 pi 2. So for the sine inverse function, so where y-axis is positive, right? That's what we need to keep in mind. 0 to pi over 2. Where it is negative, negative pi over 2 to 0. Or imagine it that we are going backwards, right? Or the clockwise, right? So in the fourth quadrant, it is negative. In the first quadrant, it is positive. So the range restriction is quadrant 1 and quadrant 4. That is the range restrictions. On the same hand, for cos, let's construct another teeny tiny unit circle really quick. Let me construct the lines again. Okay, much better. So we have quadrant 1, 2. More time. I'm sorry. Here we go. So we have quadrant 1, 2, 3, and 4. Now understand where the cos function is positive. So cos is positive from 0 to pi 2. That means in the first quadrant. Cos is negative in the second quadrant. That means from pi 2 to pi. So quadrant 1 and quadrant 2 are active. So the range restriction is quadrant 1 and quadrant 2. Tangent inverse always works as per the sine inverse function. So the range restriction for the tangent will be quadrant 1 and quadrant 4 only. So tangent is positive from 0 to pi over 2 because everything is positive in the first quadrant, and negative pi over 2 and 0. And as I said earlier, it behaves the same way as the sine function. So in the same scenario will be quadrant 1 and quadrant 4. Now we have the basics of it. Let's try a few things. Let's try a few examples. So it says find y is equal to sine inverse of 1/2. So ask yourself at what angle the value will be 1/2. That means at sine y, what sine y is equal to 1/2. It will be at pi 6th. So sine restriction is at in quadrant 1 and quadrant 4. And 1/2 is positive. So that means it will be in the first quadrant. Now y is equal to sine inverse of negative 1/2. The value is negative, and the sine restriction, the range restriction for sine is quadrant 1 and quadrant 4. And in quadrant 4, sine is negative, right? So it will be negative pi over 6. So as you can see, if you understand the unit circle summary chart, tackling these problems would be a little bit easier. Let's take a few more examples. Now we have y is equal to sine inverse of radical 2. Now ask yourself, at what angle y the value of sine will be radical 2? It is undefined because radical 2 will give you 1.414, and on the unit circle we cannot have any value more than 1, so it is automatically undefined. Now we have cos inverse of negative 1. Cos y, that means what angle of y will give you the value of negative 1? Negative 1 will happen at, remember for cos it is quadrant 1 and 2, so quadrant 2, which is pi. Let's take one more example. Now this time tangent inverse of negative infinity. This is very, very interesting. At what angle y the value will be negative infinity? Remember, for the tangent the restriction is in quadrant 1 and quadrant 4. In quadrant 1 it will be infinity, and in quadrant 4 it will be negative infinity, which is at negative pi over 2. So infinity implies it is undefined. So tangent is undefined at 90 degrees. Because it is negative, so we are going in the quadrant 4. Now this problem is very interesting. Y is equal to cosecant inverse of radical 3 over 2. When we graph the cosecant function, we talked about it. Instead of graphing the cosecant function directly, we graph the sine function first, and then on every hills and valley, we bounce up or bounce down. So mini lesson, how to derive the angle, how to convert it into a sine function. So can I rewrite y is equal to cosecant inverse x as cosecant y is equal to x? Now cosecant y can be written as 1 over sine y is equal to x. Let's do some cross multiplication. So 1 over x is equal to sine y. Can I take the inverse now? Can I say y is equal to sine inverse of 1x? Aha, this is what we need. You can see we started with y is equal to cosecant inverse x, and that can be written in terms of sine inverse if I take the reciprocal of the angle. So if I have to convert y is equal to cosecant inverse radical 3 over 2 into sine, it will be y is equal to sine inverse of 2 over radical 3. So the angle, which is x in this case, is the reciprocal, and that will give you sine y is equal to 2 radical 3. And again, it is not possible on the unit circle. So this is a very, very important proof that we just did in the mini lesson format, how the cosecant function can be written in the sine inverse function. And the same way we can write the secant function in terms of cos function, cot function, secant function in terms of cos function, and cot function in terms of tangent inverse function. So jot down these important points. So cosecant inverse, we just did it. Cosecant inverse x can be written as sine inverse of 1 over x. Same way, secant inverse x can be written as cos inverse 1 over x. Tangent inverse can be written, cot inverse can be written as tangent inverse 1 over x. So whenever you encounter these kind of problems, just switch them into sine, cos, and tangent format. Let's take more examples. we have cos sine inverse of 2/3. Now, this type of function is called a composite function. So the composite functions are those where we have a function inside a function. For example, f of gx, right? So a function inside a function. So inside function will be as a new function, right? Or new x. So sine inverse 2/3 is nothing but the angle of cos, because cos, sine, or tangent or any trig cannot function without any angle. So sine inverse, let's separate it, the inside function first. So I can write sine inverse 2/3 is equal to theta. On the right triangle, I know sine theta is nothing but opposite over hypotenuse. So opposite is 2, hypotenuse is 3. Can I use the Pythagorean theorem to find the value of adjacent side? So if I use the Pythagorean theorem, the adjacent side will be 3 squared minus 2 squared inside the radical. That will be just radical 5. Now I know all the side lengths of my right triangle. What is left? Cos theta. Because the inside is sine inverse 2/3 and we solve it as theta. And we know cos is nothing but adjacent over hypotenuse. So you just have to use the understanding of SOHCAHTOA. Let's take one more example, another composite function, function inside a function. So what is the angle for cos in this case? Angle is sine inverse of 1. So let's tackle that. I can do it two ways. So sine inverse 1 is equal to theta. That means sine theta is equal to 1. Either I can create a right triangle and find the missing side line, that means the adjacent, or think along the unit circle. At what angle sine will be 1? Right? So I know sine will give the value of 1 at pi over 2. So what we are looking for? What is cos pi over 2? What is cos pi over 2? It is just a 0. Because pi over 2 is the vertical axis, that means 90 degree. At 90 degree, cos is 0 and sine is 1. One more example, another composite function. Sine, the angle in this case is tangent inverse radical 3. So can we say let tangent inverse radical 3 is equal to theta? And then tangent theta is equal to radical 3. Now just look at the unit circle. At what value? It is at pi thirds. So when theta is pi thirds, the tangent will be radical 3. So sine pi thirds is nothing but radical 3 over 2. Having a good understanding of the unit circle, especially the first quadrant. If you understand the first quadrant, technically you know the whole entire unit circle. One more example. Now cosecant and inside function is tangent inverse of -1, which is theta. So tangent theta is equal to -1. At what theta, what angle will give tangent as -1? It will be negative pi fourths. Remember, what is the restriction for tangent? Quadrant 1 and quadrant 4. In quadrant 4, cos is positive and sine is negative. So it will give you a negative. And because it is cosecant, I need to flip into sine. So cosecant theta can be written as 1 over sine theta. Don't forget to rationalize it because we don't like radical in the denominator. So ultimately the answer will be negative radical 2. One more example. Okay. This time let's take cosecant of tangent inverse 1 over x. So tangent inverse 1 over x is equal to theta. Tangent theta is equal to 1 over x. For this one, let's create a right triangle. So we know tangent is nothing but opposite over adjacent. So opposite will be 1 and adjacent will be x. So the missing side length in this case is the hypotenuse. Use the Pythagorean theorem, and when you use the Pythagorean theorem, you will get radical of 1 plus x squared as the hypotenuse. C is radical of 1 plus x squared. So cosecant theta. Now, you know cosecant theta can be written as 1 over sine theta. In this case, I'm talking about cosecant theta. We are not talking about cosecant inverse theta. When we talked about cosecant inverse, we changed the angle of the sine inverse, right? So two things are different. So the answer is just radical of 1 plus x squared, because SOHCAHTOA is flipped. Okay, let's take secant. Now, secant inverse. So it is not a composite function, right? So if I have to write in terms of cos, I need to flip the angle. So it will be 3 divided by 2 radical 3, but I need to rationalize it. Do you think it will be possible to solve for this function? Because if you think of rationalizing it, what you will get? You will get radical 3 over 2 radical 3. Yes, radical 3 over 2. So 3 and 3 will cancel out, radical 3 over 2. Can you think about what value it should be? Pause the video, think about it, and let me know. Will it work? If yes, then what will be the answer? So remember, cos inverse radical 3 over 2 will be theta. Cos theta, at what angle cos theta will be radical 3 over 2? Think about the unit circle. It will be 30 degrees. Okay, now we have secant inverse 2 radical 3. Let's see what will happen with this one. So cos inverse will be radical 3 over 2, and that will be same as like it. Thank you.